Hello everyone, welcome to this video. In this video we will see the question that is next permutation, and this question has been asked in many interview rounds of the big companies like Amazon, Google, etc. And in this question we have to implement a next permutation which rearranges the numbers into the lexicographical next greater permutations of number. So lexicographical also means that dictionary order, so it means that they are increasing in their number. For example, in this we are given 1 2 3, so its next permutation will be 1 3 2, which is greater than this permutation lexicographically. So that's a dictionary order or lexicographical order. So if such arrangement is not possible, it must arrange to a lowest possible order. So what does this line mean is that if we are at highest possible permutation, that is like 3 to 1, so it is the highest permutation for the 1 to 3 sequence. So we have to print the starting permutation. So there is no permutation after this. 3 to 1 is the last of its sequence, so that's why we have to print the starting permutation for the same. And we are given the replacement must be in place, and we only can use extra space, only constant extra space. So here are some examples, that is 1 2 3, so its next permutation is 1 3 2, and for 3 to 1, as we saw, it is the starting permutation. Answer is the starting permutation, that is 1 2 3. And for 1 1 5, similarly the next permutation will be 1 5 1. So let's dive into the solution and see what approach we should do for this question if we are asked in an interview. So if the interviewer asks you this question, first of all you will start with a naive approach, which will be, if you are given this input, so you will tell him that you will generate all the possible combinations possible. That is, for this permutation, this sequence, we will generate all the possible combinations. It will be 1 2 3, then it will be 1 3 2 and 2 1 3 and 2 3 1, then 1 3 1 and 2 and 3 2 1. So when you have generated all the possible combinations then of the particular sequence, then you will tell him that you will linearly traverse through this sequence where you have stored it in array. Then you will check for the input that you are given, that is 2 3 1. Then you will linearly traverse this array and you will find 2 3 1. Then you will break this loop here. Then you will print the I plus 1 index value, that is 3 1 2. So it is the next permutation for 2 3 1. But this approach, so I have written the pseudocode here. You can see generate all the possible permutations of the sequence and linearly traverse for the permutation that we are given, then print its next permutation. But in this approach the time complexity will be exponential time, because we have to generate all the possible combinations. Here the sequence is small, but if you will be given sequence like 4 1 2 3 4, it will be larger than that. So that is like 10 up to 10 numbers, so that will be really difficult and really time consuming, and it will require linear time for finding the element and searching the element. So if you tell this approach that this is good for starting, then interview will ask you to optimize it, because you also know there will be a way to optimize it, because this will not be feasible approach. So let's dive into the optimal solution. First of all, I will show you some patterns what we have to observe for a particular question, and in this question specifically, that is also called as case analysis. So you can see when we are starting up a particular permutation, then you can see first of all the permutation are in sorted order. You can see they are all sorted 1 2 3, then 1 3 2 is bigger than 1 2 3, then 2 1 3 is bigger than 1 3 2. So they are in sorted order. You can see now we have to see how we are forming this permutation. Basically, first we are writing the first variable, smaller value, that is 1. Then we are exploring all the possible combinations or permutations that can be formed by 1. So first permutation will be 1 2 3, that is a decreasing order, because we are printing the decreasing order first, then we are increasing the values. So next permutation will be 1 3 2. So first we are exploring 2 value, then we are exploring 3. So now we are not left with any value for 1, any permutation for 1. Now we will change the 1 with 2. So now we will explore all the permutations of 2. Then first will be 1 3, then will be 3 1, because we are finding the permutations in increasing order. So to make them in increasing order, we will first of all explore all the smaller possibilities, then the larger than that greater possibilities. So similarly for when we have explored all the possibilities for 2, then we will explore all the possibilities for 3, that is 3 1 2 and 3 2 1. Similarly, now we will dive into the larger bigger example. So here the example is 4 1 5 3 2. So we have to print its permutation, next permutation. So first of all, you need to observe one pattern, that given a permutation, there will always be a decreasing decreasing sequence in a permutation. So you can see from like 4 1 are decreasing, but they are not the longest. So you can see that 5 3 2 are the decreasing sequence, or you can see non-increasing, that is 5 is greater than 3, then 3 is greater than 2. So if you start from here, the value is increasing, and you start from here, the value is decreasing, that is strictly decreasing. This is known as strictly decreasing. I will write it here. So it is a decreasing order. So you can see they are in decreasing order. So this is one pattern that we have to observe, because in dictionary also, if you see, there are, first of all, the values are increasing for a certain period of time, then there will be a certain breakpoint. You can see this value is from 5, the values are increasing, 5 decreasing, 5 3 and 2. But if you see at this index, the sequence is getting like broken, because the 1 is smaller than 5. So this is a break point for particular permutation, and 5 3 2 are in decreasing order. So as we saw here, if we are in decreasing order, that is 2, then for exploring two possible permutations, if we write 3 1, so 3 1 is the maximum permutation that we can form for 2. It is a maximum possible combination that can be formed for 2. So for this also, we have to find a particular point whose all permutations have been explored. So for 1, after 1, the elements are in decreasing order, that is 5 3 2. So means once all possible permutations or combinations have been explored. So 5 3 2 are in decreasing order. So means we have to change the 1 to find our next permutation. So to find our point where we have to change the point, and we have to form next permutation. So for that, we have to find, first of all, where is our breaking point, where is our sequence getting broken due to the non-decreasing subsequence. So you can sub array like that. So you can see we have first of all found the point where our sequence is breaking. So now if you see, we have to replace the 1 with the number which is just greater than that, because here also you can see we are not changing the 1 with 3, because we have to find the next element which is greater, but not like we have to find the greatest element. So we are exchanging it with 2 to form the next permutation, then we are exchanging it with 3 to form the next permutation of 2. So we have to increasing lexicographical order, or you can say a particular sorted sequence. So for 1, we have to exchange, we can exchange it with 5 or 3, but they won't be the next possible permutation after this permutation. So to find its next permutation, we have to change it with the next possible just like greater than or closest value. So it will be 2. So we have to replace 1 with 2. So I will write here, just we have to exchange with just greater element, and you can find the greater element. If you see, we have to if you want to find greater element, you can think we have to traverse to this array after this index, but it is not the case. You can observe one pattern, as I told you, it is a decreasing sequence. From here it is a increasing sequence. From if we start from this point, that is 2 3 1 or 5, so then we can simply find a linearly traverse through this ending of this array, and we can find a value which is just greater than 1. So if we start traversing from here, so if here is a value that is 0, so it will not be the greater than 1, but if we go to 3 or 2, so it is just greater than 1. So we can just simply find the value that is just greater than 1 by traversing to the end of the array, which is at this point. So we traverse from the end of the array, so we will find 2. Now we will just replace the 2 with 1, swap the 2 with 1, so it will be 4 2 and 5 3 and 1. So this will be what we are left with. So after replacing the 2 and 1, so you can see we have swapped this 2 with this 1 and this 1 with this 2, you can vice versa. So this is one thing. Now to form this is not the next permutation after this. We have found a point to replace the number to form the next permutation. This is not the next permutation. Actually, you can see, because this will be 4 2 and 5 3 1. So it will be the last possible combination, or the exploration for 2, because this is in decreasing order. So you can see here also it is 1 5 3 2. So this is the last of its combination for 1. So to make this the just next permutation after this, we have to reverse this. We have to sort this, you can say 5 3 1, but we will not have to use the sort function because they are in decreasing order. So if we just reverse them, they will be sorted automatically. So if we sort this 5 3 and 1, it will then become 1 3 and 5. So this will be our next possible next permutation for this sequence. So you can see we have just swapped the value that is a breaking point with the just greater value than that, and then we have simply reversed the array from the that point. So then we will get the next permutation. Let's dive into the algorithm. So you can see this is algorithm. First of all, we will find a particular index, this index whose value is if we are on this point. Okay, we are on this point, so we have to find a value if this value is smaller than the next value, because for a decreasing sequence the first value should be greater than the next value. But at this point you can see for 1 the first value is not greater than the second its next value, so 1 is smaller than next value. So this condition says we have to find that, and suppose we have I will write it as index 1, so it will be I will write as idx1, so it will be 1. So we have found an index at where our sequence gets broken due to the non-increasing value. You can say non-increasing value, that means 1 is smaller than 5. So that is the first step. Then we will just find a value that is greater than 1. So we will start from this point. So we will start traversing from this till this value, if till idx1. So if we start from here, we check that if idx of this last index is greater than this value. So yes, it is greater. So we will just swap this element. So if we swap them, they will become they will become like here it will be 2, and here we will be left with 1. So to form the next permutation, we will have to reverse the value, or you can say sort this value, but they are already in decreasing order, so we can just reverse them using a reverse function, lbit function. Then we will end up in sorting that. So it will become 1, and here it will be 5, and here it will be 3. So sorry, here it will be 3, and here it will be, what's happening, here it will be 5. Just a second. So this you can see. So in this way we end up having a next permutation for the particular input we are given. So you can see I've written all the permutations for this. So you can see 4 1 2 3 5. So first of all we start with a smaller value first of all. Then we explore all the possible combinations for the smaller value. Then we change it with the just greater value than that. So you can see here also I have written that 4 1 3 5 2. So our input was 4 1 5 3 2. So which is 4 1 5 3 2. So this is our input. So this is our input. Then we have to find the next permutation for it. So you can see we just swap the 1 with a just greater value than it, that is 2. Then we just reverse this array. So we got the next sequence, which is 4 2 1 3 5. So this is one thing. Now if we are given a sequence where there is no breakpoint, that is if we are given like 5 4 3 2 5 4 3 2 1. So this is the last sequence, as we saw in the case here. We saw in here that if we are given 3 2 1 3 2 1, so it is the last sequence. So we have to write the first sequence for the first permutation for the particular sequence. So you can see we did that. And now for if we start traversing from here for finding this index, if we end up getting our index to -1, so then you can see our index is -1. So that means we have not found any point which is breaking the sequence, that is a non-decreasing sequence. So what will it say? That we will get to know that it is a edge case, and there is no possible permutation after this this particular permutation that we are given the input. So then we will have to just do one thing to form the first permutation for particular sequence. We have to just reverse, just a second, we have to just reverse this sequence. So it will become 1 2 3 4 5. So this will be our output if we are not having any breakpoint. So that's one thing. Now the time complexity for the particular solution will be actually n, O of n, because we are not sorting anything, we are just reversing the array and array, or if we are not having any breakpoint, or we are just reversing the half array because after the breakpoint. So that's the time complexity for this solution. And the space complexity is O of 1, because we are just swapping the values and in place. in place because we are not using any extra space unlike the first solution. So this is the optimal for this. Let's see the code in C++ and Python, and I will show you the code on Leetcode platform. So let's see. So here is the code for the particular this solution. So now you can see, first of all we have to find the breakpoint. So finding the breakpoint, I have to set the flag. So flag will be our index 1, you can say. And let's see. So we will start traversing from the end of the array, and then we will check if we have a particular point. If we have a particular point, then we will set its flag to I-1 because the loop will end up at this index, that is 2. For this value, loop will end up breaking at this index. So then our flag will be I-1, which is 1. So that's why we have written I-1. Then we will break and we will check if flag is -1. If flag is -1, that means it is a base condition because we are ending up having no breakpoint. It is the last permutation of its sequence. So then we will simply reverse the array and return it because that will be our next permutation for the particular, because we have to return starting permutation. Now we will check for the value which is just greater than the particular flag value that we have found, the breakpoint. Then we have found, for example, in here we have found the 2 value, that was 2. So then we will just save its index, that is m. I am saving the index in m. Then I will swap the values that we have found. Then I will just reverse the array from that point to the flag +1, because we don't have to reverse from this point, we have to reverse from this point after swapping the value. That will be, if we will have 5 3 1, then we will reverse that. So that is one thing. Now we reverse the array, and let's see submit the solution and see if it's working. So in here I use the sorting function, so it actually took less time than the reverse function, but the reverse will be the optimal way, more optimal. Let's see the Python code. So it got submitted. Let's the Python code. In Python I've started from the second last index. So I will check if this particular index is smaller than I+1 index. So in this I'm checking like that, and we will break when the condition is true. Then we will break and we will check if I is not equal to -1, because if it is equal to -1, then it is the base case. So then we will find the value which is just greater than ith value or our flag value that we have to swap. Then we will swap the value. Then we will just, I've used the list slicing and just coded it in one line so you can understand it if you know Python. So I've just reversed the number if it is a -1, and if it is not equal to -1, then I have reversed the array after a breakpoint, particular breakpoint that we have found. So let's submit this solution also. So I will give you the code in the description so you can download it from there. So it got accepted. Thank you for watching, guys. This was the solution for next permutation. Hope you like this solution and found it helpful. So do subscribe this channel and like this video and share this video. Thank you guys for watching.